my name is Ines Hiltz. I'm a lens creator from Berlin, and today I will show you how to build 3D games in Lens Studio. We will build a very simple jump and run game where the floor is lava. We will go over the asset library, how to set up the Bitmoji as the player character. We will spawn some assets, detect collision, and many other useful tips and tricks. This tutorial is very beginner friendly. You don't need any experience in Lens Studio or in coding. Make sure that you're using Lens Studio 5.15 or higher to follow all the steps. From the start screen, you can click on this big Snapchat button and you will find 2 in-depth tutorials that you can go through, and many useful templates and also some games. For example, a platformer game and also a endless runner game in the style of Subway Surfer. I would highly recommend you check out all the templates they have and use them as a jumping off point. But today we will build a full game from scratch, so you see how easy it really is to build games with Lens Studio. So let's create a default project. First of all, I want to set up a character. In the Snapchat app, every user has their own unique Bitmoji. So let's use that as a player character. In Lens Studio, you can find a lot of useful building blocks inside the asset library. Here you can find a lot of cool and useful building blocks. I would encourage you to spend some time and just explore the different sections. They add new assets all the time, so it's nice to open it once in a while and check all the new features. We will need the Bitmoji player package, so I will import that into my project. So now that it is imported, you can see that we already have a character that we can control with this joystick here and a jump button. And it automatically added some scene objects into our project. We have a Bitmoji player package with a character controller script where we can change all the different values, how fast we're moving and jumping. You can play around with these so that it fits your idea. It also added a camera controller and a ground plane. It also added a orthographic camera that is used to render the UI elements or 2D images on top of the 3D scene. So with one click, we already have a player character that is just fun to move around and to jump. So first of all, let's turn the floor into lava. I'll go back into the asset library and just look what kind of materials they have to offer. For our use case, I think this dynamic water wave might work really well, so I will just import that as well. It already added a little mesh, a sphere with the material on it. I will just delete it for now and click on the ground plane. In the material slot, I can select the water material. And now I want to make some adjustments. So now I can right-click on the material and press select. This will automatically select the material in the asset browser. And in the inspector, we can change all kind of values. I don't want this plane to be animated. For this, we would need a mesh with a lot more polygons. So I will just scale the strength down to 0 and play around with the scale values. To turn it into lava, all we have to do now is change this blue color to a very deep and satisfying red. And just like that, we already have a lava floor. I will scale it up quite a bit so that it will stretch till the horizon. And adjust the scale again so that we have a nicer effect. That looks really nice. For the final game, I want to change the camera perspective. For this game idea, I actually don't need the camera to follow the player. So in this case, I can just disable the camera controller and place the camera manually where I want it to be. So I want it to be kind of a top-down perspective. So I will move it here and also rotate it downwards. I will also change the clear color option to a color, and now I will just select a darker red. To bring back the user, I can go in the orthographic camera and add a screen image, and inside the texture of the material, I can select the device camera texture. Let's bring up the 2D editor so we can move around this camera texture. And I will just scale it down and move it to this top right, I think, and set the stretch mode to fill and cut. We can also add a masking component so we can make the edges round or even turn it into a circle. Let's adjust the rotation of the camera a little bit more so we have less of an empty space on top. Now we should also add some elements that we can actually jump on. Let's create a prefab that we can later instantiate with a script. For now, I will just use a box. Let's scale it up. And I'm also adding a collider component so that the Bitmoji can actually stand on it. I have to set the type to box, and it will automatically fit the mesh visual. We have to turn this into a prefab so we can instantiate it. Let's create a new scene object and call this prefab1. And I will just drag the box inside of the prefab, so it's a child object of this one. Now I can drag the whole prefab into my asset folder. This will create a new prefab here. Let's actually create a folder for our prefabs, so everything is nice and tidy. Now the icon changed for the scene object. If I just duplicate it a bunch of times, if I go in here and change something, for example, scaling it up even more, and I press apply, now all of the other scene objects will also take on this change. This is the start of our little obstacle parkour. But I want to change the camera angle so that we look at it from a side view so we can't see where the prefabs will spawn in the end. So I will just select the camera and rotate it a bit. Next, let's make these platforms actually move towards us, so we have to jump over them. In Lens Studio, we have a very easy way to add simple animations to any scene objects. For that, we want to import the tween manager. So I will just search for the tween here and import it into the project. This will always create a little bit of a mess in your project, but don't worry, you can just go in here and delete all of those examples. And also in the orthographic camera, you can just delete those. It's just important that we keep the tween manager and that it's at the top of the scene always. Now I'm going back into the prefab. I will create a new scene object, calling this tween animations. And when I click on add component and I search for tween, you can see that we have many options to animate this. We can animate the transparency, for example, the color, but if you want to change anything related to position, rotation, or scale, we need the tween transform. In here, you can decide which object should be animated. So I can just drag in the prefab wrapper. We can leave out the name for now because we are playing it automatically. Since it should be a continuous motion, I will change the type to offset and set the Z value to 20, for example. I want to add the offset continuously, so I will set the loop type to loop and also check the additive check mark. So it always adds the offset to the current offset that we already have. It's not moving in a linear fashion, and we can change this in the easing function section. I will just set this for linear. And now you can see it's moving slowly but continuously down the camera. You can also change the time, so the animation plays faster if you put a lower number and slower if the number is higher. You can add a delay, so it will wait for 2 seconds before it plays the animation. In our case, we don't need a delay, and I think 0.5 was a pretty good speed for now. Again, I need to apply these changes, so all of our platforms will start to move. So now we have 3 platforms that are moving towards us and that we can jump on, but we don't want to build the parkour manually. We want to instantiate these platforms as long as the game is running. So let's get into some very simple scripting to instantiate these prefabs for an endless stream of surfaces to jump on. For now, I will just disable these prefabs. And I will go on this plus in the asset browser and just type script. And I will use a JavaScript file, but you can also write TypeScript. I will name this game controller. And now I can just drag and drop it into the hierarchy. And I also want to move this on top of the hierarchy, but underneath the tween manager. Let's open it with a right click and edit. You can also double click it down here. So let's go in here and create an input field for the prefabs we just made. If I save this now and select the script component, an input field appeared where we can drag in our prefab. So now we have a reference to what we want to spawn. I also want to have an easy way to control where the objects are spawning. So I will create a new scene object that is our spawn point. And I will also reference this inside the script. To instantiate our prefabs, we just have to reference the prefab with script.platforms. And then we just write instantiate. And in here we can decide if it should be instantiated as a child of another scene object. And in this case, we want to use our spawn point as the parent. Let's save. So now you can see one platform spawned right at 0. So I will have to go in and move the spawn point further away. Let's enable the first 3 ones so I have a reference, like somewhere here. So now we have the first 3 plus an additional one that we just spawned. Let's wrap this instantiation into a function so we can call it over and over again to spawn a continuous stream. And I will just move this in here. Now I also have to call this function underneath so it actually gets called. Now I want to add a small delay before we spawn the next platform. For this we use a delay function, and I already made a little script snippets library for this case because you basically reuse the same script snippets all the time. So if you're new to scripting, I can highly recommend saving all these little code snippets that you learn into your own file so you can easily reuse them. Here we have the delay function. I will just copy it and paste it in here. So everything inside of this delay event will get executed after 2 seconds right now. So let's call the same function in here for an endless spawn loop. You can see that now they're overlapping, so 2 seconds is not enough time right now with the speed we currently have. So I will also create a variable that I can change the delay from the inspector. Let's set the default value to 2. And instead of hard coding the delay, I will use my new spawn delay variable in here. So now I can change the delay from the inspector. Let's maybe set it to 4. It's still a bit close, but I think I will just increase the speed of the platforms because they're going quite slow. It's a bit hard to debug the jumping in here, but you have to just try it on your phone and see what feels right. So far so good. Let's change these gray cubes into some nicer assets. We have multiple ways how to decorate the game now. Lens Studio has a really interesting new feature called Gen AI. This is the AI suite from Lens Studio, and this lets you generate game assets for free. For example, if you want to add new animations to the Bitmoji, you can either animate it in Blender, download pre-made animations from Mixamo, or just generate them here in the AI suite. For games, we can utilize the texture generation and the asset generation. For example, I can generate a low poly stylized star, generate some previews, And if there's one you like, you can just select it and generate the asset. This will take some time, but you can always close the window and come back later. But if you already have some assets ready, you can just drag and drop the FBX file or any other 3D model file into the asset browser or the hierarchy itself. Before I do that, I will create a new folder to keep everything nice and tidy. I got some very simple furniture models that I will just drag in here. So let's go into the first prefab and drag in this bed model. And it already kind of matches the cube we just made, but you can always adjust it a bit more. We don't need the cube visuals anymore, but we do need the collider. So I will just go in here and disable the render mesh visual. When I apply the changes now to the prefab, we have a stream of beds floating towards us. To add some variety, we can create multiple different prefabs and spawn them randomly. So I will use the second one here and first of all unlink it from the prefab. So any changes we make in here will not be applied to this first one that I want to keep how it is. I will delete the bed again and drag in the table, just adjusting the transforms. Already looks pretty good. I will just scale the size of this collider a bit smaller. I will rename this prefab to prefab 2 and drag it also into our prefab folder. I will do the same with this one and just add a different asset. So now we have 3 different assets. Let's go back into the script and make some changes so it instantiates a random one out of the 3. First, I want to turn this reference for the platform into an array. So I will just add 2 empty brackets in here. This turns the input field into an array. We can add values here by selecting all these prefabs. We have an error now because we're instantiating an array right now. So we have to go in here and also add the brackets and select an index between 0 and 2. So it knows which one of the objects it should instantiate. I want to randomize this index though, so I will create a new variable called random index. And we can use a function to generate a random index. So we write math floor, and inside of here I will do math.random multiplied by the length of our array platforms. So let's use this random index inside of these square brackets. So it always chooses a random prefab from this array to instantiate. And when I save the script, you can see that it will always generate a random asset now for us. One thing that I like to add is a drop shadow so the players know where they are jumping and running. For the floor, I want to add a shadow plane, so I will press the plus and search for shadow plane. This will automatically create a plane that is still a bit small, so I will increase the size. I think my light wasn't rotated correctly. We also want to have shadows on the furniture, so we can just go into the prefabs and select the meshes, and I will set the shadow mode to receiver and then apply the changes. Before we continue, let's set up a basic UI so we can keep track of the score and add a simple game over screen as well. For UI elements, we will go into the orthographic camera and I will just create a new screen region for the game UI. And I have this selected and add a text, a screen text, and rename this to score. I will anchor it to the top left and go back into the 2D scene editor and drag it up here. Let's align it to the left and add some very basic styling. Okay, I'm happy with this. So let's go back into the script and create a function that increases the score every second. I'll create a variable that keeps track of the current score, and in the beginning this is 0. Then I will just reuse this delay event, copy paste it in here, but instead of calling this function, of course we don't want that, we will increase the current score by just typing current score plus plus. And this should happen every second. After I increase the score, I want to call this delay event again. So I will just take this line and paste it in here again. Let's actually rename the delay event so we don't get confused. Now I want to set this score text to the current score, so I will need a reference to it. So again, input, I'll just drag it in here. After we increase the score, I want to update the score text. So I will write script score text.text is the current score. But because the current score is a number, like an integer, and the text needs a string, we have to convert it to a string. And of course, I also have to call this function once the lens loads. And now you can see that every second the score increases. Because we will also have a game over event where we want to stop the score from increasing, I will add a little check in here already if we are game over or not. So let's create a new variable up here, game over, and this is set to false when the game starts. So now inside of this function, before we do anything else, we check if game over is true. We want to return out of this function. So this whole section afterwards will not get called and we automatically don't restart the loop of increasing the score. We can test if this works by setting game over to true from the start. So now the score shouldn't even increase. That works perfectly. So let's go back to game over is false. Let's add a simple game over screen. So I will go back onto the orthographic camera, select the plus, and do another region. To make it look really nice, I want to add a blur effect. So let's add a Gaussian blur as a post-processing effect. I want to keep the player image over the blur, so I can just drag it underneath the game over screen. Because Lens Studio is rendering from the top to the bottom, it's rendering the blur first, and then on top of the blur, we render the player image. We still have the joystick visible on top of the blur, so I will just go in here, select the joystick, and set the render order to 0. On top of that, I will add a simple game over text and show the final score. Now I also want to update the final score, so I go back into the script. And then I just copy paste this line. And instead of the score text, I will use the final score text. Also, the final score is like updating every second, but we want to add another string in front of it that says your score. So we can combine a text, for example, your score, with a number by adding just a plus. And because we're combining those two, it automatically converts it into a string. So we actually don't need this end part here in this case. So let's disable the game over screen for now and enable it later once we have the game over logic implemented. Because right now we can't really lose, like I can just walk on top of the lava, nothing happens. So let's look at some collision events. For the game over, I want to detect if the Bitmoji is touching the floor. So let's add another box component that will serve as a collider. And I will just scale it really big and add a physics collider. Let's set it to box and it will automatically fit our box mesh. We can disable the visual again, and I want to make sure to set the collider to intangible. We also have to go into the character controller and disable this ground is 0 checkbox. So now we just fall through. The Bitmoji has some character events that we can use. So if you add a value here, we can add an event in case the Bitmoji overlaps with a different collider. And here we have to specify what collider, so I will just drag in the box. Let's actually rename it to floor collider. And then we can define what should happen when we are overlapping with the floor. So I will add a value here. And now we can call a function inside our script. I'll drag in the game controller here, and I will call the function game over. This function doesn't exist yet, so let's go in the script and create it. And because I want to be able to call it from another scene object, we have to turn it into a script function. So we just write script game over is a function. And inside here, let's just do a print message. You died. So now whenever I touch the floor, it gives me a little print that I died. Now I have to move the Bitmoji controller up a little bit because it automatically collides with the floor whenever the lens loads before the Bitmoji is actually there. I just move it up a bit and reset. So now we don't get this message anymore once the lens loads. Now inside this function, I first of all want to set our game over bool to true, so the score stops increasing. Next, I want to enable the game over screen. For that, we still need a reference to it. And then I will set the game over screen to enabled. Nice. One last thing I want to add, I want to animate the furniture down into the lava as soon as it reaches the end here. So I will go back into the prefabs and add another tween transform script. But because we can't use two tween animations that change the same value on the same scene object, I will just create a new wrapper, tween wrapper, where I will add the collider and the visuals both inside here. And then I will move this object with both the visual and the collider. I will move it down by 300. And after a delay of, let's say, 8 seconds, and here I just play around with the values until it looks right. And because the first 3 furniture items are already close to the camera, I will just change the time in here, but I'm not applying it to the prefab. So it will only be this bed that will disappear after 2 seconds, and every other bed that gets spawned will go after 13 seconds. You might also want to either destroy the prefabs after they sank underneath the lava, or just reuse them and set them back to the beginning, because now every time we spawn a new furniture, it will just live forever until you close the lens. And that can like really add up over time and really decrease your frames per second. So now we have a fully functioning game and we can just play around with the values, the speed, and add some polishing. Right now, this game is pretty simple, but if you decide to make it a bit harder over time, you can, for example, increase the speed of the animation or increase the distance of the furniture. You can add moving parts or distractions. You can add little collectibles like the star we just generated. So players are motivated to do more risky jumps and fall into the lava eventually. But for this tutorial, I think we covered already a lot. If you have any questions, feel free to drop them in the comments or go to the Discord. There's a big developer community that can help you out. I really hope this video was useful to you and you feel prepared to build your own 3D games. And just remember to have fun with it and to experiment. And I can't wait to see what you're gonna build. See you!